Welcome everyone to Plastics Frontiers webinar series. The Plastics Frontiers webinar series was developed by the collaboration between the Royal Australian Chemical Institute, Society of Plastics Engineers Australia New Zealand and Society of Chemical Industry. We are thankful for the sponsorships from BSF Australia, Reckitt Benckiser, Qenos and Foundry Intellectual Property. For any concerns, please reach out to RACI. We are also thankful to the organising committee, Gary Bowman, Chair of RACI Industrial Chemistry and Dr. Yvonne Ma, Han Michel, President of the Society of Plastics Engineers Australia New Zealand and Dr. Steve Petanakis, Jenny Sharwood, OAM of the Victorian Education Committee for RACI and Dr. Richard Tweets, also Chair of Society of Chemical Industry. The purpose of the series is to highlight the continually evolving role and important contributions of plastics in society, some key societal and environmental issues faced by the plastics industry, and how the industry is rising to these challenges with new innovations and practices. With our backgrounds in education, industry, and academia, we are reaching out to as many sectors ranging from secondary chemistry teachers and students to researchers and innovators in industry and in universities. We hope you enjoy this series. Thank you for watching.
Is support of the Society of Plastics Engineers and the Society of Chemical Industry. And we also, as organizations, would like to thank our supporters and our sponsors, and particularly Foundry IP, Reckitt Benckiser, Qenos, and number 4, Yvonne is, by memory, because I don't have it in my memory.
BASF.
BASF. See, how could I forget that? Thank you, Richard.
All right.
Good. I introduced Tim Grant. Tim is the director and founder of Lifecycle Strategies. He is a specialist in life cycle assessment, LCA, with over 20 years of experience in developing and applying LCA with a wide range of companies and organizations. He is an author of the book Life Cycle Assessment, Principles, Practice and Prospects, published by the CSIRO in 2009, as well as a co-author of the book Design and Environment. Tim works across many different sectors in LCA, including packaging, agriculture, energy, fuels, water products, buildings, and waste management. In addition, he has worked on the development of LCA databases for Australia. Tim obtained a master's degree in science from RMIT. Please welcome Tim.
Thanks, Han. Thanks for the invite and welcome everyone. Nice to be here on our last night of lockdown in Melbourne, where I am. So yes, the brief I got from Hans was just to talk about life cycle analysis in the context of making the production and use of plastics more sustainable. I thought I'd just touch on a few topics that are of interest in that area. I'm not going to go into a lot of detail about how LCA works and things. I thought I would just touch on some areas that maybe are of interest, and then we can have some Q&A around that. Just a bit of background on life cycles. So I've been working in this area, as Hans says, for over 20 years, and in the relating to plastics for nearly all of that time in just a sample of sort of activities. Back in the early or late 90s, Don Burke came on the TV and said recycling was a waste of time, except for these little Tetra Pak cartons which you can make a tree out of, and that incensed the Victorian Recycling Authority to actually instigate one of the first really large policy LCA studies undertaken on the recycling of HDPE, aluminium and PET containers, I think, and it took us like a year to do that study. It was all very new and there was no data around. Since then, we've done a lot of work in the area of waste management, carry bags for the federal government in about 2005, and what was a scoping study that never had the real study completed. In 2015, Life Cycles, we purchased a packaging impact quick evaluation tool, which is an eco-design tool for the packaging sector, which we still maintain and develop. We've done a lot of work on disposable food serviceware, recently did a bio-HTP bottle for Fonterra, and just this year been looking at the chemical recycling of plastic waste. So always doing things in the area of plastics and packaging. But as Hans mentioned, in life cycle assessment, because you really got to cover the whole economy and you need to be a bit adaptable as a consultant, we end up working across many, many different sectors. So, one of the, I think, key things around, why we engage life cycle assessment is to be making better decisions with actual evidence of impacts. So connecting decision making to relevant and measurable and relevant impacts. When we do that, we want to take a broad integrated perspective on environmental impacts and not just optimizing for one thing, for recycling or for bio content or for embodied energy. People are very confused about what are the most important environmental impacts. And the other thing is to, in looking at trying to make better decisions using things like LCA, you want to have the appropriate level of analysis for the decision context, and I'll talk a bit more about that. Well, the way LCA operates is we look at the world broken up into the technosphere, which is the realm of human activity or the economy where we actually do stuff. We convert materials into products, we use them, and hopefully we cycle them around. And every time we do that, no matter what the product is, there's always some things, stocks and flows of substances being drawn in to the economy, and there are substances being released out of the economy back into the environment. Now, of course, this is not a real boundary because the economy and the environment sort of intermingle. You can be, the environment is essentially everywhere, but as a conceptual framework, things are in the technosphere, in the economy, while we manage their fate. When we cease to manage the fate of a substance, like we set fire to some natural gas and the CO2 and NOx and particles disappear into the air, they have been released back to the environment because we're no longer retaining their management. We build a model that analyzes all those stocks and flows in and out of the technosphere for a given amount of functionality, and then we relate that to indicators that matter to us. And so they can be things like, we can relate the CO2 and methane to climate change, we can relate water use to water scarcity, we can relate particles to particulate matter, and so forth. So
Tim, I'm going to interrupt you. Are we supposed to see slides?
Oh, yes, you are.
Good.
Okay, so what happened there? I thought I pressed the share and it didn't. There we go.
Yeah, that is there.
Okay, but it's probably the wrong one. Hold on. Absolutely seamless. This new share that screen there. Excellent. Sorry about that. Okay, so yes, this is the wonderful diagram I just described of how flows flow into the technosphere and out, and we relate those flows to our really the areas of concern that we have. And in life cycle assessment, they are generally defined around human health, ecosystems, and resources. although even that is a little bit up for debate at the moment. So it's important that when looking at life cycle assessment, that we, just like in a financial decision making, the amount of effort you put into any LCA study really is relevant to the size of that question. And so sustainability will come in the forms of some really big decisions, big investment decisions, a change of a product line, government policy relating to materials or recycling and EPR and those sorts of things. And then there are the day-to-day, small choices, minor changes to products or personal decisions or consumer decisions, either within business or for individuals. And we now have a range of tools that really operate down at this really simple level. And we have, I think, the cost of doing LCA up in the bigger sort of policy, big investment area has also come down enormously over the last, over the 20 years that I've been doing it, but particularly over the last 10 years. Some typical comparisons, one of the things that we see from the tool PK, which is used by lots of different companies, we see them doing types of studies that are done. There's a lot of assessments of plastics against liquid packaging board in the and also glass and other materials. We have also plastics versus composite cans, polystyrene versus paper foam or cardboard, single-use polyethylene bags and paper shopping bags, and a lot of work on composite film products against basically competing containers, and EPS. Oh, I repeated that twice. From lots of those things, it's important that each study, that in the context of each study, things, local things matter, and specific shapes and types of materials and types of applications matter. So it's important that you can't overly generalize, but there are a few things that we tend to know that would come out of those studies. But before I do that, it's worth just thinking through, in the area of life cycle assessment, there's always been, ever since it was developed in the 90s, there's been this broad group of indicators that have been used and thrown around, and they often muddy up the results from LCA studies because people don't understand half of the impact categories. And what's happening is also over the, I suppose, 25, 30 years of LCA, is that the importance of different impact categories is changing over time. So if we think about a group impact category these days into three groups, the impacts where we are winning, and so these are, I would say, is photochemical ozone creation. So here, because of vehicle improvements and also VOC emission reductions from refineries and the petrochemical industry, we've really set, the days of the LA smog is a thing of the past. You might get it on extreme summer days, get a level of haze, but really the significance of those emissions have dropped enormously. So I would say that's a real tick to us. Ozone layer depletion, obviously the control of CFCs. So this appears to be on the improve. It had slowed down a bit in the last couple of years, but they say it's back on track. I think there was a bit of illegal use of materials that were still leading to some depletion. But that you would say we more or less ticked that one off. And acid rain through acid gas scrubbing and low sulfur fuels. We've managed to solve the issue of acid rain in most places. It's still a little bit in China. There's some acidification that goes on, but more or less we've dealt with that issue. And it's a concern because in a lot of the LCA studies and literature, you will find those three indicators still regularly reported, even though no one really cares that much about them as critical outcomes to your decision making. If we then look at impact categories where we still have challenges, climate change, this is the big one, obviously. From the models that we've got on the total impacts of everything on everything in the world, if you look at the total damage to species and human health modeled forward from where we are now, climate change accounts for just over half of all damage from all sources of impact are now predicted to come from climate change. So it is way out in front of all other indicators. Eutrophication, this is one where I'm tempted to put it in the we have it under control. We have reduced emissions from runoff, better control of agriculture, but the counterflow of reduced water availability actually means that that eutrophication still, particularly in Australia, is a significant issue, and also in pretty much every other country where there's where you've got inland waterways. Toxicity and ecotoxicity, again, we've improved a lot on the control of substances and our understanding of toxic substances and the banning of particular substances in certain products. However, we have an increasing list of emissions, and we also have time going on. So if we think that some of these substances will accumulate more over time, then this risk maybe goes up. And the toxicity and ecotoxicity, it's sort of like one of those ones where it's less predictable that we will have a certain issue in a certain place and time compared to other indicators. But when it does happen, it's generally pretty nasty. So that remains certainly on the watch list.
Tim.
Yes.
Can you do a full screen?
I am a full screen.
But not on my computer and other people. Yeah, that is already better.
Ah, okay. Newish areas for concern. They're not really new, but they're sort of new to LCA. Land use. This is because, they say buy land, they're not making any more of it. It's exacerbated land. The stresses on land are going to be exacerbated by climate change. But this is a very low impact area for plastics. And if you are going to, a lot of the competitors to plastics are actually coming from land-based product systems, be it paper, cotton, wool, and obviously bioplastics as a competitor to fossil-based plastics. And so for any of those comparisons, it's really important to look at land transformation and occupation if you're going to compare synthetic products with, inverted commas, natural products. Water scarcity is another one, which again is not new, but I suppose the way we look at it in LCA is newish, where we really actually look at a catchment level. Our data now is mapped, and that's because it really matters where you use water. There are places where there's plenty of water, there's places where it adds an enormous amount of stress, and we tend to grow things in the areas where there's a lot of stress. So very much linked through to more the agricultural demand for water. The other big one is particulate matter. So these are the winter smogs as opposed to the summer smogs, and kills around 5 million people per year before the pandemic. So really the pandemic's almost caught up to particulate matter as a source of all-cause mortality. And I suppose that's the bad news about particulate matter. The good news is it's more or less controllable. It's not quite like climate change where, like you can't just filter CO2 out of your emission stack, but you generally can filter particles out of a lot of combustion processes. It's improved a lot from vehicle emission technologies, but it's getting worse from burning off and bushfires, as we all found out just before the pandemic in the bushfire season in Melbourne and Sydney, New South Wales and Victoria, where you couldn't be health impacts from those particulate matter are quite significant. The other, I suppose, downside for particulate matter is that it still has significant impacts well below emission levels. So at levels that you would consider to be not problematic, that actually still does have a impact on hospital admissions, and epidemiologically they can see that it is damaging. So what do we find when we compare some of these off plastic and paper type products? We typically find that the plastics have higher impacts on climate change per unit mass than competing products, but they are nearly always lighter per unit of product and therefore end up being usually ahead on climate change impacts. And often many of the other impacts that are connected to combustion-related processes and energy will be significantly improved through when you look at LCA of plastic versus competing products. The only one where plastics generally has a negative impact would be on things like litter and maybe on fossil fuel depletion. On that issue of fossil fuel depletion, if we look at this other main area where people go, oh my God, we mustn't use this plastic because it's made from fossil fuels, and people will go and look at alternative materials. I would say that in the world, which is now is constrained in terms of the amount of carbon that we are able to combust, that the actual depletion of fossil fuels is now much less of an issue than it was back 20 or 30 years ago when the Club of Rome and we were all worried about peak oil and the price of gas was going up and the price of oil was going up and it was $2 a litre for fuel. And then all of a sudden we found actually we can just get fuel and gas from every crack and crevice in the earth. And so the actual supply of fossil fuel feedstocks far exceeds the planet's capability to oxidize all that fuel. So for the plastics industry, this really means that you have nearly all of the remaining hydrocarbons at your disposal because you will eventually not have to compete with the energy industries for that feedstock, which sort of says trying to come up with alternative feedstocks to fossil fuels for synthetic materials doesn't really seem to make any sense from my point of view. The only advantages you get from the biomaterials is the actual extraction of carbon from the atmosphere in the growing phase of the product, but that will have counter impacts on the land and water required to do that. The other area where people are often concerned in the issue relating to plastics is where they get sent to landfill, and there's this very worrying that the plastics will be in landfill for 500 years. When plastics go to landfill, not very much happens. Low climate change impacts relative to any other organic products where you'll have degradation and methane generation. Plastics will have much lower impacts. The greater the degradation time for the materials in the landfill, the better it is from the environment's point of view. You want those materials to actually remain intact rather than beginning to degrade. So typically, while no one ever really points to landfill as a good technology, from the point of view of negative impacts from something going into landfill, plastics certainly nearly always outperform competing products. The counterbalance there is that if you look at combustion of plastics at the end of life, this is usually a poor option because the fossil carbon contained in the plastic currently is still a fossil carbon, even though maybe it's had a really useful life as a clamshell or as a TV or as whatever product it is. At the end of life, the carbon in the plastic is still classified as fossil, and therefore if you pop it in make a biofuel from it, gasify it, pyrolyze it, whatever, to produce energy products, you still essentially release fossil CO2 to the atmosphere. Where if you do the same activity to a wood waste or a bio waste, then typically you won't have to, that will be considered biogenic CO2 and you won't have it counted as an impact against your product system. So there is a number of efforts to make useful things from plastics at end of life. If it involves oxidation of the material, that generally will be not that easy to get across the line, particularly from a climate point of view. And even from a processing point of view, the processing impacts of most of our fossil fuels are so low that trying to make a competing product out of mixed waste plastics can be really, really difficult. That brings us to the litter and microplastics, which I could have put in, initially had it in as one of the new areas of concern, and it's certainly is an area of concern. There's not much new about it, because I think I have here, Keep Australia Beautiful, founded in 1968, and there's a nice picture of ABBA wearing Keep Australia Beautiful t-shirts. Essentially, we have been worried about litter ever since plastics really came into the domain, and they have this persistence, and so it's certainly not new. LCA was actually really developed mostly by the Swiss in the early 70s and 80s in response to concerns about plastics and plastic litter and non-degradable plastic products. So it's a very problem that's been around for a very long period of time. Having said that, it is, and I'm probably speaking to the converted here, that the issue is potentially being driven by a lot of imagery. It's never a good look to see plastics in the environment. But if you look at, say, these pictures of cotton buds, you would be wondering why the cotton buds all collect themselves into little piles on the beach. And I think that's because they never were there in a pile on the beach. Someone has gotten a bunch of cotton buds and placed them on the beach and taken a photograph. I don't know why cotton buds were being picked on. They're not something you carry out with you. They're something normally in the home. But I think that seahorse has a lot to answer for, because that one image really represents somehow this very awful thing that this poor seahorse thinks that's its mother that it's holding on to. So I think whatever we think about the litter and microplastics debates, we will need to get it under control in some way, because it's not going away. The emotional arguments are really, really strong, even if when we look at the science, we don't see necessarily the same level of damage to species caused by litter as we do by other impacts. So if we think about the sort of species damage, was it 500 million species were killed in the bushfires just pre-pandemic? On top of that, we've got bees, polar bears, the Great Barrier Reef. All of these things are not suffering because of litter or polymers. They are suffering because of climate change. And so in any decision to, remove a plastic cotton bud for a higher climate change impact alternative would be a bad decision, you would imagine. But we're much more, we're very tactile, and so these impacts are somewhere else, while the impact of that cotton bud in your bathroom or maybe on the beach when you find it really connect. I think I've had the...
Is that the last one, Tim?
Yep.
Okay.
Sorry?
Is that the last one?
Almost, yep, 2 more. Okay. I think the issue of plastics litter really needs to be treated in the same way that we treated sewage back in the day when Melbourne was called Smelbourne, because it was awash with sewage. No one really took responsibility for the management of it. So I think really what plastics litter needs really is a management solution that is pretty extreme. We've had 50 years of warnings of everyone being annoyed with litter, and now we're finally getting sort of action where we're being deselected because of plastics are being deselected because of this issue, even though maybe it's not the biggest issue that there is. So to make plastics more sustainable, get to the actual title of what I was meant to talk about, need to demonstrate the impacts and benefits of plastics over alternatives. So that can involve making data available in databases and tools. All the data that's out there is really, a lot of it is very old and outdated. Publish LCA reports, very few are published. Also look at the possibility of environmental product declarations, which are a way to really stamp the declare the impacts of your product. And finally, manage the fate of materials over their life with a world-class producer responsibility scheme. I think the plastics conversion, one of the biggest impacts from plastics, 30 to 50% of impact is often from conversion. And so taking advantage of electrification of the economy and via clean grid power can actually really bring the impacts of current plastic products down substantially. Don't always be the cheap disposable option. So, you know, a bit, if we have responsibility, there are probably products that shouldn't be out there, and the industry should maybe try and take some leadership on removing as many of the single-use products as possible where it can be done without higher impacts from the alternatives, and providing centralised recycling infrastructure for products rather than the current system where, you know, it's fairly ad hoc, individual products having mail-back solutions and all sorts of very inefficient solutions. Something that is, I think, as centralised and efficient as the way we make virgin plastics is how we want to deal with plastics at end of life. So that's me. Thanks.
Thank you very much, Tim. This is a fantastic overview. I think you gave us a lot of information to think about, and I will give the time a little bit to the audience in the interest of time, and I suggest that we deal with questions when we have the panel discussion. So thank you very much, and I was actually very much encouraged by the fact that quite a number of the comparisons didn't look so bad for plastic as once in a while the media intend to let us believe. So thank you very much again. I would like now to introduce the next speaker. And the next speaker is Dr. Nick Florin, or Florin, probably in English.
That's right.
Dr. Nick Florin is currently a research director at the Institute for Sustainable Futures at the University of Technology, Sydney. His research involves policy options analysis, technology and infrastructure assessment, and stakeholder engagement to improve policy relevance, resource stewardship, and supply chain sustainability. Recently, he has advised the New South Wales government on circular economy policy and led a major research project for the Australian Packaging Covenant Organisation. Nick also has partnered with Queensland and ACT governments, as well as the Australian Battery Recycling Initiative and the Battery Stewardship Council on projects supporting the development of product stewardship for clean energy systems. He is an honorary lecturer at the Grantham Institute on Climate Change and the Environment at Imperial College London, and Nick has a PhD in chemical engineering from the University of Sydney. Please welcome Nick.
Thank you very much for that introduction. I'll just share my slides and confirm that people can see my slides in full screen. Thumbs up.
Yes.
Excellent. Okay, thank you. Well, yes, thanks for the introduction and thank you for the invite. Unfortunately, zooming in from Northern Illawarra in Greater Sydney, I can't say that I'm in the last day of lockdown or homeschool, but you know, there we go. I'm going to pick up, I suppose, a little bit where Tim left off in terms of talking about management at end of life and stewardship approaches. Very quickly about the Institute for Sustainable Futures, which is a transdisciplinary research institute based at the University of Technology with a mission to create change for sustainable futures. We an assorted collection of researchers, engineers, economists, social scientists and architects, and as was mentioned in my introduction, my background is chemical engineering. We undertake applied policy research with industry and government collaborators across a whole range of different areas: climate adaptation, renewable energy, resource stewardship, and circular economy, which is the focus of my presentation this evening. I lead the resource stewardship research team at ISF, and essentially a large sort of focus of our work is promoting sustainable production and consumption by fostering product and resource stewardship and circular flows. I'm going to sort of base this talk on a number of recent projects. My team works across a range of fields: textiles, metals, electronics, and e-waste, organics, as well as plastics and packaging, which is why we are here this evening. These images on the slides are sort of the title pages for some recent projects that my presentation is based on, including some work with the Australian Packaging Covenant Organisation. For many years, I've been working with APCO, which is the sort of a leading industry-led stewardship organisation in Australia, championing packaging sustainability. And the focus of a lot of this work has been on tracing packaging flows through the economy from consumption to recovery at end of life, and also appraising different strategies or interventions to support a shift to a more circular economy for plastics and packaging. And the other image here is actually a project that's ongoing, working with technology consultants, Pegris, and label makers and Dairy Australia, as well as the recycling industry, to dramatically increase the rate of recycling of HDPE milk bottles back into HDPE milk bottles, or at least food grade packaging materials. My group at ISF is also part of a new Product Stewardship Centre of Excellence that we host in partnership with the Australian Industry Group and Coxonal, a communications company. And you know, the focus of the centre's work is really to accelerate the uptake of product stewardship and extended producer responsibility activities in Australia, working with business and working with product stewardship organisations. So product stewardship is whereby those organisations, entities responsible for putting products onto the market take responsibility for the product across the whole life cycle, including at end of life. And it's a key strategy, I think, as Tim also mentioned, in terms of supporting a sustainable plastics economy. And indeed, there are already numerous examples of initiatives, stewardship initiatives and activities focused on plastics and packaging, including Red Cycle, focused on soft plastics or flexible plastics, APCO, of course, and the container deposit schemes. So I guess I'd like to just step back now and sort of consider the sort of the problem or the issue that we're confronting, and certainly as the point has been well made, plastics are incredibly useful and you know, and fundamental to our economy, but the way we use them is unsustainable. And the case for sort of changing the way we use them, I think, has been well made by organisations such as the World Economic Forum, the Ellen MacArthur Foundation, McKinsey's, and in particular, sort of as portrayed in this, the idea of the new plastics economy. And this is one of the images from that work, and it essentially shows the flow of plastics packaging through the economy. The key thing that we see is that, you know, the vast majority, 98% of plastic packaging is derived from virgin sort of fossil-based feedstock. After use, about 85% is burned or buried or leaks directly into the environment, and only a small fraction is collected and recovered from recycling, about 15%. But of that 15%, only 2% is recovered at a quality that is suitable for packaging applications. So a lot of it's being downcycled. So to shift from this system, you know, there's opportunities to make a whole range of changes across the whole life cycle, and that's sort of what I'm going to be talking about. One of the sort of overarching visions for how to transition to a sustainable plastic economy or a sustainable circular economy is shown on the slide here. You know, what I have here is a fairly simple diagram illustrating a shift from a linear economy to a circular economy. So in a linear economy, and obviously our current economy isn't strictly linear, you know, raw materials are extracted, or we produce stuff, we use stuff, and then it's disposed at end of life. Whereas in a circular economy, the aim is to minimize resource inputs, minimize waste by design, minimize emissions and energy use, maximize the value of the resources in use. And so this is, for example, by using products more intensively, that could be through sharing platforms or reuse models. A circular economy aims to keep resources in use for as long as possible. And this is about how we design our products, designing products for durability such that they last longer, or designing products such that they can be repaired to extend the useful product life. And it's also about recovery and regeneration at end of life. So recycling is certainly very important and fundamental to the concept of a circular plastics economy, but you know, it's only one part of it, and the transition to a circular economy involves changes across the whole system, and it's not simply a waste management challenge or an end of life challenge. So for the remainder of my talk, I'm going to focus on the Australian packaging context, and this image here is an output from some of our recent work with APCO that shows the flow of packaging through the in Australia in the 2018-2019 financial year, from consumption to recovery at end of life. We consumed about 6 million tonnes of packaging, which was placed on the market. About 1 million is plastic packaging, and after use, we recover about 50% of it. Of the recovered materials, half is exported overseas, and about half is utilised locally, some for packaging applications, but also other industrial applications. We also lose about 50% to landfill, and part of these losses are associated with how packaging is designed. So it's not technically recyclable or not economic, and you know, and this includes some composite materials, and we also lose some to landfill just due to the inefficiencies in the sorting and reprocessing. But you know, these processes are fairly well established. The vast majority of losses is associated with poor disposal practices. So it's collection losses, and this includes you know, recyclable packaging ending up in the red bin. It also includes, you know, litter and dumping. In the case of plastics, we end up disposing about 800,000 tonnes per year. So the recovery rate compared to the average recovery rate for packaging is lower. So this slide actually focuses in on that data, and sorry to sort of present a lot of numbers, but I really just wanted to draw your attention to those that are highlighted with the blue box and the red circle. But as I mentioned, plastic packaging compared to you know, the average packaging has a much lower recovery rate of only about 18%. I think it's improved slightly since 2018, 2019. We're currently digesting more recent data, and even for PET, soft drinks and HDPE, milk bottles and shampoo bottles that are relatively easy to recycle, and where there are strong end markets, we're only achieving recovery rates of about 36 and 23% respectively. Considering milk bottles and in particular natural HDPE, for which there is a very strong kind of secondary market demand, and you know, relatively easy to recycle, we're failing to collect about 60%, and of the 60%, about close to 50% is loss owing to just sort of poor collection practices, and the remainder is due to sort of a lack of collection services or access to convenient collection services. So essentially what you can see is that the very low rates in terms of recovery is in a large part owing to sort of the poor collection. And in the case of milk bottles, where the product is relatively easy to recycle, and one that you might assume that most people are aware that it is recyclable. So we have a challenge in transitioning to a more circular economy. In the next slides, I'm going to discuss the policy responses and the industry response. So one of the key policy responses to the challenge for packaging was the establishment of the 2025 national packaging targets that were endorsed by all government, and APCO is essentially responsible for championing and coordinating a packaging sector approach to meeting these targets, these voluntary targets. There's the first key target is that all packaging placed on the market is recyclable, reusable, or compostable, and we're actually tracking reasonably well towards that target. It's estimated that about 90% is technically recyclable, reusable, or compostable. The second target, which is specifically focused on plastics, is to actually achieve a 70% recycling rate for plastics. And as you can see, we've got a further way to go in terms of achieving that target, with a recovery rate of only about 18% for plastics. The third target is the recycled content target, and currently we're at about 38%. And that is largely sort of buoyed up by the high recycled content in glass and fiber packaging. In the case of plastics, it's sitting around 14% for PET and much lower for HDPE and polypropylene and very little, if any, recycled content for many of the other polymers. And then the fourth is is a target to eliminate problematic materials, including PVC labels, polystyrene and expanded polystyrene, and packaging containing sort of fragmentable additives. The other key sort of policy intervention is the waste, or is the implementation of the waste export ban. And it's not strictly a ban, but rather a limitation on exports of unsorted recyclables requiring further cleaning and reprocessing. In the case of plastics, which by mass represent about 13% of the materials that are impacted, the ban is being ratcheted up. Presently, the direct export of mixed plastic bales is not allowed, and that's sort of shown in the image on the top right. And about this time next year, unprocessed single polymer bales, such as these milk bottle bales, will not be allowed to be exported, such that only clean and flaked material can be exported, which is shown here. So it's about essentially adding value and doing more sorting and cleaning on shore. And as I mentioned, aligned with the national packaging targets, we're seeing a significant commitment to phase out certain problematic, unnecessary single-use plastics, and this is largely focusing on some of the offending items in Tim's images of litter, straws and cutlery, EPS for takeaway food and beverage, and this is really being driven by state and territory jurisdictions, and the timeline of these phase outs is shown here. We are also seeing significant industry response in terms of new investment in reprocessing capacity, and I believe just yesterday there was an announcement for a new HDPE recycling facility in Melbourne by Pact Group, and I don't think that's included in this estimation, but greater than 250,000 tonnes per year of additional capacity in plastic reprocessing has been announced and is expected to come online in the next year, and this in the next years, sorry, next few years. And this includes recent announcements for rPET and RHDPE, which are food grade, including another project with a joint venture with Pact and Cleanaway. If you consider the high rPET and HDPE capacity, currently it's estimated at around 10% per tonne, 10,000 tonnes per year, up to about 90,000 tonnes per year by around 2025, which is the time frame for the targets. And it's important to sort of flag this. This is capacity for like or closed loop recycling, which is sort of an essential part of the strategy towards a sustainable circular plastics economy. So I guess at this point, just kind of wish to raise the questions where, whether we are doing enough, and whether the changes are going to deliver a fundamentally different system aligned with circular principles, or whether they're going to simply lead to sort of incremental change, and whether the change is happening fast enough. So this slide in a way summarizes some of the interventions I've mentioned and others. So we're seeing at the front end of the supply chain, a move to phase out problematic materials. But at the moment, the recycled content in new packaging going onto plastic packaging going onto the market it remains very low. At the back end, the processing and new end market, we're seeing significant investment in new reprocessing capacity, as I've mentioned, buoyed by the export ban and sort of supported by government funding. But there is still a significant challenge in terms of dramatically increasing collection, and this includes increasing collection for flexible plastics. There are initiatives and interventions that are focused on this, including the Australasian recycling label that helps inform consumers, whether packaging is recyclable, and also expansion of CDS, which is and separate collections, which is sort of improving access and convenience of collection, which is critically important. But I think, I guess, by way of conclusion, it's clear that the individual interventions are sort of not going to deliver, a shift to a sustainable circular economy, and what is needed is really a multitude of coordinated interventions across the supply chain. I've mentioned a few, but on this image, I'd just like to sort of mention a few more. The image on the left is of an award-winning temporary building installation constructed using waste plastic that's been upcycled into building materials, and I've included this image partly because the architect is a colleague of one of my husband, a husband of a colleague, but I think it's also a great example of rethinking waste and creating something that has a higher value, essentially upcycling. The other image in the middle is a new tax to be introduced in the UK that incentivizes businesses to use recycled content versus virgin, and I think this is a key intervention that can help grow new end markets and address the challenge in increasing the recycled content, and it remains to be seen how the rate of change with a voluntary mechanism compares with a sort of a more stringent regulatory approach. And the final image is of a reusable plastic crate, a sort of a simple innovation, but the use of a reusable plastic crate that offsets the use of a single-use alternative is a great example of a new business model, and wanted to include this to highlight that the solution is not only technical innovation or policy innovation, but innovations in business models such as reuse, which also sort of is about changing how we access and consume our plastic products, and I think that's a critical part of the solution. Just very quickly, I'd like to give a bit of a plug for a new cooperative research centre on waste plastic that UTS is a part of, sort of championing along with Griffith and a range of partners. CRCs are one of the key collaboration models between industry and research. They typically span about a decade with multiple partners and aim to solve the really sort of pressing problems for industry and the community, including transitioning to a circular plastics economy. This one is focused on plastics waste, but also looking much more broadly at medical plastic waste, agricultural plastic waste, textiles and e-plastic waste. So if anyone is interested in participating or finding out more, I'd be very happy to chat or make introductions as appropriate. But thank you.
Thank you, Nick. That is very well done, and I'm very grateful that you tackled so many issues in actually a very short presentation, and it is gives us a good overview of the enormous task ahead of us, because I still think it is enormous.
I agree.
But fortunately, there are lots of solutions. They only might take a bit longer, and we have to live with that. I would have liked to open the floor for some questions, but we are about 10 minutes delayed, and I would like to switch that to the panel session hereafter. So thank you very much again, and I would like to switch to Dr. Tim Zerk. Dr. Tim Zerk is currently an assistant director with the Federal Department of Agriculture, Water and the Environment. Tim joined the department in 2019 as a policy officer after his studies at the University of Queensland. As part of one of his more recent projects, he has been involved with the preparation of the ban on the export of mixed plastic waste, for which the first stage came into force on the 1st of July 2021. Before joining the Department of AWE, he was a researcher at the University of Queensland for 9 months. He obtained a BSc Honours Class 1 in Physical Sciences and a Bachelor of Education in Secondary Education and Teaching from the University of Queensland in 2013, and he completed his PhD from the University of Queensland in 2017. Please welcome Tim.
Thanks, Han. Good evening, everyone, and thank you, Han, for the invitation to present here. Let me just pull up my presentation, and as I do, I'll clarify that I'm working from Canberra at the moment, but my home is Brisbane originally, and yes, I did my PhD at University of Queensland there. I worked with Mike Montero, who works on controlled radical polymerization to form plastics. So I have a bit of a background in plastics, and I did a couple of postdocs over in the US and Spain before starting work for the department. So I've also been a member of RACI for a long time. So it's a privilege to be able to jump on here and talk about something quite different from what I'm used to doing. So let me get started. I'm here mostly to talk about the ban, although as was accurately described, it's not a ban on waste plastic exports. Technically not a ban, but it's just easier when we call it that. So those of you who have been around the traps for a little while will be aware that back in 2020, in March, I think it was in 2020, the former Council of Australian Governments, or COAG as it was called, they agreed in partnership with the Australian Local Government Association to ban or regulate the export of waste, 4 streams of material waste. So those were glass, plastics, which is obviously the key one of concern and relevance this evening, and tyres and paper. I thought I'd mention a couple of the drivers for this, and some of these you're probably aware of, and some perhaps a bit less familiar. Obviously, the China sword policy was one of the key drivers that came into effect in 2018. So up until that point, China, for the last 25 years preceding that, had been receiving roughly a quarter of the world's recyclable waste up until that point, and they introduced a ban on the imports of most of the plastic and other materials that were headed for those recycling facilities in China. So that placed additional pressure on other countries to receive those diverted waste streams. And what we ended up seeing was diversion of waste to countries that couldn't handle it appropriately. So the fate of that waste was that it was theoretically intended for recycling, but in practice ended up being landfilled or just dumped in various places. Another driver that was happening in parallel was the amendments to the Basel Convention on the transboundary movement of hazardous waste, and redefining what plastic waste was covered under the convention. And as those amendments came into force, different countries began to adjust what they considered acceptable contamination levels in waste imports. And so Australia was seeing more and more containers of waste knocked back from those countries as they set lower and lower thresholds on what was acceptable in those waste consignments. So as I mentioned, the confluence of these things sort of led to the regrettable situation where waste wasn't actually being recycled, it was just being dumped. And it was being sent principally to countries that contribute to around that 90% mark of the global plastic pollution that's going into our oceans. So Australia recognised that, you know, we aren't taking responsibility for our waste. We're sending it to places that don't have the ability to do that, unfortunately, and the risk to the environment, human health, was just considered to be unacceptable. So those were the drivers really for the implementation of this export ban or regulation. And it was really that point there is Australia will now take responsibility for what we generate. So I think this is pretty standard. The ban was brought into effect through this new act that was introduced in late 2020, December 15, I think it was, that the Recycling and Waste Reduction Act was agreed to in Parliament. And that act does a couple of things. The waste export controls is one of the things. It's not the only thing that act does, but it does set up a licensing and declaration scheme for waste exports. And I'll talk about that a little bit more in the following slides. So there's the primary legislation, which is the Act, and underneath that sit a bunch of subordinate legislative instruments, which are these rules, so-called, and they're basically just regulations that apply to each specific waste stream. So the first cab off the rank was the ban on the export of waste glass, and I'll talk to that in the next slide. And so the rules for glass have been developed and published, and the plastics rules have also been developed and published since they followed on. And then tyres is currently under development at the moment, with paper and packaging to be developed down the line. So the development of the rules, I should flag there as well, is something that takes place with heavy consultation with business, with industry, and with NGOs participating in that as well. Okay, so this is kind of the timeline for the export ban. So glass, as I said, the ban came into effect from January early this year, which means that glass must now be processed to a particular state before it's eligible for a license. And all waste glass now needs all waste glass exports now need that license before it can be legally sent overseas. Plastics, as Nick mentioned, is a two-phase ban. In the first phase, there are certain plastics that are eligible for waste for export as waste, but they must be single polymer plastics. They must be contain, I think it's described as almost free of contamination and other types of waste, and they must be packaged in a way that guarantees that they'll be accepted by the receiving country, or as near to guarantees as you can manage. In terms of mixed plastics, the only type of mixed plastic waste that is allowed for exports is as part of process engineered fuel, where a low percentage of mixed plastic waste that's been collected from particular sources is combined with C&D waste or something like that, and can be sent to facilities for co-incineration in things like cement kilns and that kind of thing. So that's the first phase, and then again, as Nick said, the requirements will take a step up in July next year. So that plastic waste will now have to be processed to the point where it's basically reusable or recyclable. So that's your flakes and your pellets and that kind of thing. There's also information here about paper and cardboard, but I won't dwell on that for the moment. Okay, so what do you need to do? What does this all lead to? Well, it means that if you want to export waste plastic in Australia, you need a license. And to get a license, you need to apply through the government's new Waste Export Licensing and Declaration, or WELD portal, which you can go online and find. And basically that portal will ask a series of questions about, information that you need to provide to help the decision maker decide whether the kind of waste that you're intending to export is the kind that the rules allows for and the kind that the Act allows for. And so there's information requirements on which polymer type it is that you're seeking to export. You need to provide information that says, yes, I have a commercial relationship with the person or place that I'm sending this to. That can be an established relationship or a relationship that's agreed to go ahead. And really the idea is to provide as much guarantee as we can, that waste is not going to just be landfilled, it's going to be recycled or reused for some purpose. And then there's also requirements about specifications, and this is kind of a new thing in some ways to industry. Specification sets out the typical requirements for wastes of that type. So if you're dealing with PET, you might have a specification for baled PET bottles that says this is the typical packaging arrangements that are used. These are the typical levels of contaminants that are acceptable. These are the types of materials that aren't acceptable to be present in that baled material. And so those specifications help us to assess whether or not that waste does meet the objects of the Act around being almost free from contaminants and being intended for use in a circular sense. All right, so actually, I don't think I need to go back. No. I thought I might give you a bit of a flavour from the inside of what's this looking like from our end, and what are the kinds of things that we're seeing. There are clearly some plastics that are easier. I was going to say that fit the mold, but pun intended, in terms of meeting the objects of this new legislation. There are quite simple plastics that are high value, like your HDPE and PET, that have been collected through controlled waste recovery activities like container deposit schemes. Those are high in purity generally, they're reasonably high in value, it's reasonably easy to streamline those, and there's quite a demand for it. And international demand is okay for this. We're not talking only about domestic demand here. Typically, those products that are of high value also go for product-to-product recycling, as Nick was talking about there. That's the optimal use of the waste, going for that product-to-product recycling. So those kinds of materials and wastes are the easiest to deal with. There are also some tricky ones that are starting to come through the pipeline. And this really is the chemicals element to plastics management. So obviously plastics are polymers, which are chemicals, yes. But the tricky bit about the plastics is the chemical additives and the non-intentionally added chemicals that show up. And really those two groups present different kinds of challenges. So the NIAS is the non-intentionally added substances. We're getting more questions around, are these actually hazardous plastics? Not necessarily because of the polymer, but because of the additives in the polymer that sometimes are deliberately intended to leach out. There are some biocides that are introduced into plastics that are deliberately intended to leach out over time. And in particular products that might be fine, but if those plastic wastes are going to be recycled into another type of product, that might not be fine. And so there are some questions there about how do we define what a hazardous plastic is. And this has links again back to the Basel Convention. So the Basel Convention says, you know, plastic or any type of waste, if it exhibits certain characteristics, it's automatically classified as a hazardous waste until it can be demonstrated otherwise. And so we have these obligations to the international agreements that we've signed up to as a country to manage these wastes in a particular way. And they're not well understood, not just in Australia, but globally. So there's a lot of fun challenges there. I'll give you one example, which is kind of the one that I've thrown up at the top of the slide there. There are good sort of product stewardship initiatives or collection initiatives for containers, right? For different types of containers, plastic containers. These might be HDPE or PP containers, but some of those containers were used to contain pesticides or herbicides or strong antioxidants for laundry detergents or that kind of thing. And so we're aware through some emerging research that those chemicals from the product contained inside the plastic absorb into the plastic. And then that plastic is collected, chipped, and sent for recycling. And so we have to manage the relative risks there about how do we control where that plastic waste goes, what kinds of guarantees can we put in place to prevent what was a pesticide containing plastic becoming a something that comes into contact with food or something like that. That's an unlikely circumstance, but it's just one of the representative ones. The second thing that we're seeing that's a bit different comes back to these specifications. So this is a little bit different practice for industry, requiring the sorting and processing facilities or the secondary processing facilities who collect this waste to demonstrate as part of the license application that they're processing it to a specification that guarantees that the waste is almost free of contamination and other types of waste. That's not a common practice historically for a lot of recyclers. It is for some, and some are cruising through this with no issues at all. But for others, there's a bit of a step change there. So we're working hard with industry to help sort of develop that shared understanding of what's acceptable here, what's not, and how do we demonstrate that through the licensing process. So that's probably where I'm going to leave that. I think Nick actually did a great job of talking about how this fits more broadly within other work that government is doing. This is not clearly the only thing the government is doing. There are a range of activities in place that cover the full life cycle of plastic products, and I think Nick did a better job of that than my slide does, so I'm not going to dwell on that too much longer. The one that I will note that is a little bit different is really because we are a regulator and we manage Australia's participation in these global agreements, we have some sort of obligations that we have to keep track of under the Hazardous Waste Act, which implements the Basel Convention. And we also have obligations under things like the Stockholm Convention on Persistent Organic Pollutants, which might not sound like it applies to recycling of waste plastic, but it does in some limited circumstances. So again, it's a bit of a balancing act here, and I'm probably just going to leave it there in terms of that. And with that, I'll say a big thank you. Thanks for the invitation, Han, to be here this evening. I've just got our shared inbox for the waste export section up on the screen there. If you want to jot that down and flick us an email if we've got it. If you've got any questions about something that I've covered tonight or haven't covered tonight, please do feel free to send an email through to us and we'll get back to you as soon as we can, noting that we are massively under the pump to assess a whole bunch of license applications, but really appreciate the time this evening. Thanks.
Thank you very much, Tim. That is a very good presentation, giving a clear picture of what is all happening to us. And I still think that it might be a bit overwhelming for a few of us, because it is not simple. As I always try to explain to people who say, oh, it is easy. And then they say, no, I don't think it is so easy. And you can see that already when we start talking about specifications. People in the chemical industry know about specifications, but a lot of other people in society don't know that much about it. And that is just something we have to live with. And I think we all need to help in explaining better what can be done and what cannot be done. And that is a mammoth task. And I call on everybody who is attending this webinar to help us explaining in general what we can do better and where we are really good at, because we are also good at certain things. So we shouldn't forget that. And thank you again for the presentation. I would like now actually to start with the panel. And I have questions here, and I will start with that to cover them first. So I hope that everybody is ready of the speakers, the two Tim Grant and also Nick Florin, that they can reply. I have here a question from Olivia Rusley. Thanks for the presentation. I'm just wondering, since I still see some people binning garbage that should not go in the yellow bin, do these mixed plastic waste get sorted for recyclables? That's the question. And what's the process here for mixed waste with non-recyclables? Thank you. Anybody of you who wants to answer that?
I can answer quickly. So I guess the recyclable material that ends up in the red bin is not being recovered for recycling. So you know, it's basically being directed to landfill, and it's startling how much leakage there is of recycled material into the red bins, and that's one of the key challenges I think that we have in terms of improving disposal practices, making it easier and more convenient.
Yeah.
Well, maybe I just add to that after what has been 25 years of curbside recycling and activity, that they talk, like in the US, they talk about getting past the 30% is really hard of participation, because that's the block of people who are willing to be motivated, which sort of says to me that I used to not be sort of techno-fix, but we really should apply techno-fix to that residual bin, and be managing that on the expectation that when we're even at the highest levels, we're not going to get past maybe 50%. So if we're really serious, that we should be not having a landfill and have some sorts of processing technologies. I know there's a few that are in development, a few that have spectacularly failed, so it's not easy.
Thank you, Tim, for adding that to the equation. I personally actually think there's another issue which is not always immediately understood, and that is because we have 3 sorts of waste in Australia: the curbside, the commercial and industrial, and the construction and demolition waste. There is also leakage in those areas, and I think particularly about the volumes of plastic which currently go into commercial and in industrial streams. And we probably need to pay attention to that, from that we can do better there, and that those material or those products will come into a recycling stream as well. That is, we have seen quite a number of subjects dealing with tonight with milk bottles, and you will be surprised how many milk bottles are disappearing in the C&I waste.
Can I just add to that? So one of the actions under the National Waste Policy Action Plan is focused on specifically C&I waste recycling and recovery improvements. And then the other big one is obviously the construction and demolition waste. So just in terms of tonnage, those are the 2 big hitters in terms of opportunities for improvement.
Yeah, thank you for that addition. That's very helpful.
I'm glad you're. Oh, sorry.
Talking about construction and demolition waste, there are changes in the world, and I just would like to make people aware of the fact that in the state of Oregon, particularly in the city of Portland, there is currently a law that you cannot demolish a building from before a certain date and just don't have a plan of what you're going to do with the materials. So we see things changing in the world, that there are places where there is already a much larger concern of what is happening to our environment, and action is being taken to deal with that in one way or another. And I predict that in 20 years, we will all think in that way. And I think particularly about building here in Australia, where a lot of dwellings are only built for a very short lifetime. Coming from Holland, we still have the houses along the canals, which are usually 300 to 400 years. And as you probably know, we don't have them here in this country. So we still need to change a lot. And that is what I wanted to say about it. There is change necessary in the way we are doing things. And it takes a long time. And I know that laws help. So I hope that there will be a few more laws. Yeah, I see that there is another question. I would also to bring that up from Bill Verhagen. Hi, Tim Zerk. To be clear, the stage 2 of the waste export bans program, July 22, require plastics to be actually pelletized or granulated being exported. If not, then what is the high level difference between July 21 and July 22 phases? It's probably easy for you to reply to.
Yeah, sure. So no, not specifically to be granulized or pelletized. It's just that they need to be further processed, I think is the wording that's used there. And essentially what that means is processed to a state where a manufacturer can take that material and use it to generate a new product.
Into a flake.
Yeah, so there are some exceptions to that though. So for example, like polystyrene waste is not flaked, right? It's densified into a resin lump.
That's expandable polystyrene you're referring to.
Yeah, that's right. So as long as it's processed to that state that's usable by the next manufacturer, then yeah, that will meet the objects of the Act and the rules.
Yeah, okay, thank you for that explanation. I think there is a lot of opportunity still to do things in that area, particularly because currently Australia is importing quite a lot of flake material as well. And the question is, what is going to happen with that in the future? Are we going to see that we need to replace it with material from here? Or will we continue to do that? That is, people should realize that as well.
That's a good comment, Han. Yeah.
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 Yeah, go ahead.
Tim, I've got a couple of maybe comments, questions for Tim Grant. How you going? So, Tim, just in relation to the life cycle assessment, they're really good information and portrays really good information about packaging and so forth. But just a comment around the LCA can sometimes also be very subjective because it can also be, LCAs can be manipulated somewhat to portray a certain, whether it's something to do with greenhouse gas emissions or depends which side of the fence you sit. I mean, is there a set of guidelines or is there a template for doing an LCA more systematically?
Yeah, look, I think if you're making a comparative assertion which may be disclosed to the public, as it's worded in the ISO standard, where you're basically claiming superiority in some form from a study, then the threshold of what you have to do, you need to provide a data quality assessment. So assessing the data quality going in, it's got to be independently reviewed.
Yeah.
And these days, the quality of, I suppose, everyone's understanding of, the little tricks you might be able to pull is pretty good. And so it's not very easy these days to really manipulate a result in your favour. The thing that you, of course, can do is people don't publish things which don't show them in a good light. So, if you aren't the superior product, well, you'll do the LCA and then you'll sit on it, which is your prerogative. If it's not a competitive advantage, there's no point publishing it. It's important to know where you have a competitive advantage. So I think it's probably So that's in the more, I suppose, serious publication. There is a step before that where you have maybe a lot of, just a little one pager that a company has got commissioned or calculated themselves, which can be selective on the indicators that are chosen to put their best foot forward. So I think the system, certainly EPDs are a standard approach, which would set the rules in very strict form of how you actually present your data. It's a fairly heavy implement though. It's like it's probably a $30,000 investment for a group of products to produce EPD. So it's not a quick thing. So depending on the size and scale of the market, you may not be able to justify that for some types of products, but very popular in the building industry at the moment.
Can I comment on that? I'm very pleased, Steve, that you bring it up, and also that, Tim, that you replied in that way, because I have a concern in general in Australia, and that is that there is too simply thought about LCA. And I think it should be much more used to really understand what the best thing is for society and the environment. I can just quote a slogan which I came across, and it was no plastic, it makes 100% sense. And that was comparing plastics with an application out of cardboard. And I personally doubt that LCA analysis would be in favor of cardboard, but there are no data available on that in a very good way, as you would like to see it, and I would like to see it. So, and I see that a lot happening currently. People, because of the negative impression which plastics have made over the last 20, 30 years, and is now coming to the fore, and people seem to forget all the wonderful things which plastic basically bring to society, and advantages to having a good life.
So I can say that these days I've been contacted a couple of times where I did a bit of internal work for a startup that was producing a particular type of tissue paper. They took the internal work and stuck it on their website without permission. I was then contacted via back channels through someone else's practitioner from a major tissue maker practitioner, and asked where the data came from, and then it went back through and the people had to take it down off their website. And we've just had in the EPD area, industries challenging one another. So there's a formal review challenge process where you can say, we contest what's written there, and we went through a process. So I don't think you get away with it these days for very long if you are a player of any note or you're competing against a player of any note. So the bar has been raised. The ACCC, I think keep a reasonable eye on some of these things. So I think we've moved on from pretty much from the bad old days of manipulating studies to get particular outcomes in the LCA area.
Yeah, I think it is a very good methodology, and I also am always concerned that it costs that much, but there's no way around it.
It's getting cheaper, still,
yeah. But it is an issue, and it needs to be dealt with. And I would like actually to see that the packaging industry is taking it more seriously. That is because I think it is being required. I would like to ask the audience if there is one more question, because more I don't want to do, because we are already past 9 o'clock. But if there is still a question, please raise your hand, and or put it in the inbox.
Han, there's just one there on the low value of should we phase out low value plastics. I just think that be careful. I think that low value plastics at some point would be wrapped around high value products and providing a barrier, really technical polymer that provides great product protection, be it a food item or something. So there it is, high value while it's in use. Yes, at the end of life it's low value, but you don't want to phase out things based on entirely on their end of life when their functional purpose is really important.
Yeah, thank you for that addition.
That was a good comment, Tim. And then there seems to be a lot playing on this space at the moment, particularly around the flexibles, where there are certain components in flexibles which are functionally important to provide what you've just described. So yeah, it's a good observation.
Yeah, I'm very optimistic, if I can react on that too, Steve. Thank you for that addition. I think over the next 20 years, we will see that the main polymers which currently being used for packaging, and particularly in the flexible area, that there will become technology available in a more simple manner than mixing certain plastics with properties which certain other plastics have, and that it all will come from one polymer. I think that will happen because there are too many organizations in the world looking at those possibilities. It's just very similar to what is happening with COVID. It is maybe a strange example, but there must currently be hundreds of thousands of scientists be working on coming up with new, basically, chemicals to fight that virus. And they will be successful eventually. It will just happen. We only might need to wait a certain time. And it could be 5 years, it could be 10 years. But I'm convinced that our science community will come up with a solution. So I'm not so pessimistic. That is what I want to say. And I think we should all be patient about what our society can do in coming up with solutions. We might need to push it a bit more, but that's the only thing.
We can be just don't say it's not a race.
Yeah. No, you don't want to do that.
Yeah. So, thank you for that last addition, Tim. I would like to thank our speakers. You all have given us a very good picture of what the situation currently is and what needs to change, particularly at the design side. And I'm sure that all the recommendations are being looked at in detail and that we will see the results of it in the next 5 to 10 years. I'm very optimistic that our industry will come up with the right solutions. And I think that, I would like to give them the benefit of the doubt. That is how I would like to end for today. I thank Nick Florin, Tim Grant, and Tim Zerk for their contributions this evening. It is fantastic to see that there is all this knowledge available in Australia. And please continue to speak up because we need that in our society. Thank you for that. I also would like to thank again our sponsors, BASF, Foundry Intellectual Property, Quenos, and Reckitt Benckiser. Thank you sponsors. It is good that we have them so that we can do these things like we did tonight. And before I close off, I would like to mention that those of you who have attend also number 10, episode number 10 on the 3rd of August, because it is a very good combination of speakers, very high quality, again, and there's a lot of knowledge. And you will all benefit from attending that evening. Thank you again. Thank you also to Yvonne Ma and my other colleagues on the organizing committee. But it is, I specifically would like to thank Yvonne as the instigator of this RACI series. Thank you all and have a good evening.
Well done, guys. Well done, Han. Thank you.
Thank you, Anne.
Thank
Thanks,
you.
Rob.
Stay safe, everyone. Thank you.
Thank you,
Stay safe.
Thank you. Good night.